Assalamu alaikum wa barakatuh. So continuing on, up until now, if you look at the if conditions, the examples that I've given, for the most part, we have, let's take this example up here. If x equals 5, we print x is 5. So until now, you'll notice that most of the examples, we just have an if statement, if, and under that, we just have print statements. And in reality, it will rarely be the case that this is what you will use if statements for. Rather, one very common use for if statements and is to one very common use for if statements is to change the value of a variable based on the condition. So very rarely would you have in the real world a condition, if statements like this, where you just have an if statement underneath, you're just printing a bunch of things. That's not really useful, because printing is just simply printing on the screen. What the whole point of if statements is to be able to perform different processes based on what the condition is. So for example, let's give an example. Example 1, ex1. Let's say, for example, we have the following problem. You go to a store, and the discount on your final price depends on the final price itself, If your bill is greater than $100, you get 10%. Otherwise, 5%. Okay? So this is a very, very simple example. So you notice here we have two conditions. You have two different approaches. If your bill is greater than $100, you get 10%. Otherwise, meaning that if it is less than 100 or equal to 100, you get 55%. So this is a perfect example of what if statements, their practical use. Until now, what we showed you, it's not really practical at all. You're just printing a bunch of things. Over here is when you actually see the value of if statements. So for example, let's implement this. So for example, we'll ask the user for the bill equals to int input, enter your bill amount. Okay, so this, we're just asking the user what the bill amount is. So now you check if, so we say right here, if your bill is greater than $100, you get 10%. So if bill is greater than 100, then what do you do? Now, what you want to do, the idea is that you want to apply a discount. You get a 10% discount, okay, right here. So what we do then is we have another variable called discount equals to 10%, which is technically 0.1. Yes? Otherwise, so this takes care of this first one right here. So we have now taken care of this one. If your bill is greater than $100, you get 10%. Otherwise, whenever you see the word otherwise, that basically means else. What is the discount? It is 5%, which is equal to 0.5% is 0.05. Okay, that is 5%. So now, and then I'll add it to this question, print the final price after the discount is applied. So what am I going to do here? So now I'm going to create another variable called final price, and this is how you approach every single problem. You you try to identify what are the variables that I need. In this case, I need one variable for bill. Look at the different items that are going to interact with each other. Look at the different parts of the question that are interacting. So you know I need one for bill. And then you see discount. So you're going to need another variable for discount. And then you're going to need a variable for final price, which will use the bill and the discount. So now you create a variable called final price equals to bill minus bill times the discount. Or what you could do up here, alternatively, to make it even easier, is that you can just apply it up here. You say the discount is equal to bill. Sorry, 1 second. Yeah, right here. It'll be the bill times 0.1. And in this case, it'll be the bill times 0.05. Because over here, in order to get the discount, so let's say it's $110, it'll be 110 times 0.1, which is $11. Over here, and let's say you put in $50, right? It was 50 times 0.05, which is equal to 2.5. Okay? So that way, this becomes much more neater. And then bill minus discount. And then all you have to do is print final price. So as you can see in this example, you notice that based on certain conditions, the value of the variable changed. This is one of the main reasons why if statements are so important. Now, another example is, so this is kind of what it looks like. Now, if we want, however, up till now, we've been considering if there's two different courses of action. So in this case, if the bill is greater than 100, do one thing. If the bill is less than 100, do another thing. In many scenarios, we want to consider more than two conditions. In such cases, we make use of Elif. So what is Elif? So for example, let's say that you have a grade calculator. If person has between 0 and 90 and 100, they get an A. If they get between 70, 80, and 90, they get a B. If they get between 70 and 80, they get a C. Anything less than that is a D. Let's just say hypothetically. So in those scenarios, we use Elif. And Elif, the whole point of Elif is to be able to consider more than two conditions. So let's say, for example, we have a grade calculator. Grade equals to int input what is your grade. Okay. Now, if grade is in between 100 or 90, then you print A. Okay. Now, this is where Elif comes in. Elif, it is between 80 and let's say 89, print B. Elif, it is between 70 and 79, print C. Elif, it is between, let's say, 50 and 69, print D. Otherwise, everything less than that, print F. Okay? So what are we doing here? So first thing you notice, you can have multiple elifs for one if. However, you can only have one if. You can only have one if. That's it. You can only have one if. The order must be. Another thing you'll find is, I'm going to add the note for this down here. The order must be if first, then one or more elifs, and then number 3, else. You cannot have, for example, elif first, and then if, and then else, or else first, then if. No, it must be if, followed by one or more elifs, and then an else at the end. Okay? Also notice, I'll add right here. Also, notice that elifs must have a condition. Must have a condition. Similar to ifs. Similar to ifs. What do I mean by that? So if you look up here, you'll see that if, then you have the condition grade greater, less than or equal to 100, less than or equal to 90. And then elif grade is greater, less than or equal to 89, greater than or equal to 80. Same thing, elif condition grade is less than or equal to 79, less than or equal to 70. Elif grade is less than or equal to 69, less than or equal to 50. Else is the only one. This is the only one that has no condition attached to it. That has no condition attached. It is executed. It is executed when all of the other conditions above it are false. When all the other conditions above it are false. Okay? Now, one more thing that you will also notice is that, so that is what has to do with if, elif, and else. So again, the whole idea is that the only one that has no attached is the word else. Otherwise, if must have a condition, elif must have a condition, so on and so forth. Another very important point: if there are multiple ifs, and elifs, as soon as one of them has a true condition, meaning that as soon as one of them is true, all of the others underneath it will be skipped. Others underneath it will be skipped. So what do I mean by this? This is very, very important because I will explain to you how this messes a lot of people up in the future. Okay. So let's say, for example, you have this grade calculator. You set the grade equal to 95. Okay. You say if the grade is greater than or equal to, let's just erase this real quick. If 50 is less than or equal to grade, less than or equal to, let's just say 69, print D. Elif grade is less than or equal to 90, sorry, greater than or equal to 90, less than or equal to 100, print A. Else, print, let's just say good job. This is enough to get the point across. So why is this point so important? You want to star this and you want to remember this. Why? So let's trace this code for a second. So grade is equal to 95. So if grade is greater than or equal to 50, less than or equal to 69. Let's say hypothetically, sorry, let me just fix this real quickly. So this mistake I made here. Let's say I put this, sorry, instead. If the grade is greater than or equal to 50, you print, let's just say pass. Pass. Okay? Now, if you look at this example right here, you say grade greater than or equal to 50. Is this true in this scenario? Well, yes, because 90 is greater than or equal to 50. 90 is greater than or equal to 50. That is true. So this will then be triggered as a result, and the user will see the word pass on the screen. It will print pass. Once it enters into this block and it prints pass, it will ignore everything else. It will ignore all of these, and it will jump all the way to the end of the program. As a result, if you're creating this grade calculator, you want the user to see A, because that is what the mark is. They got a 95, it should be A. But because you put this condition first, because you put this one first, this greater than or equal to 51, as a result, this number, this condition is true in this scenario because 95 is greater than or equal to 50, and they will see the word pass. And then as a result, it will literally, once this is true, as I mentioned before, it will skip everything else and it will go all the way to the end. When in reality, what you actually wanted is for the user to see A, but instead it saw pass. This is why ordering your conditions is very important. Start with the condition with the most/highest restrictive condition. And work your way down. So in this case, 90 and 100 is the highest condition. So you start with that. Then you go 80 to 90 because that's next. And then so on and so forth. That should make sense, hopefully, inshallah.